Welcome to an example in which we're solving an inequality, and we want to graph it, and we also want to give the answer in interval notation. Okay, so how do we do it? So it's kind of a weird one. I know this looks funny, so I just rewrote it down here. See how it's a three-parter? Let me put in the lines that might help right here. So in fact, I could probably make that a little bit longer, like that. Like that. See, that's a three-parter. You call that a compound. This is I'm not going to quiz you on the names. I don't know if it really matters. I don't care at all, but you might be helped by it in case you have another class and they mention in compound inequality. That's what this is. You know, like they say, compound just means multi-part. Like if you have a compound fracture of your arm or leg or something, that means several parts are injured. So compound, it's several parts. So there's three parts. It's a compound inequality, and what we're doing is we want to solve for x. So what it is what you need to do is just focus right here on the part that has x. There's no x out here, no x out here. So just focus right in the middle and just kind of forget about everything else and just do whatever it takes to get that x alone. And then whatever you do it to all three parts. So I'm going to add 6, right? I'm trying to get the x alone, and whatever you do to one part, again, you have to do to all three parts. So we do that, like that. This cancels, right? So it kind of helps us. We're getting closer to getting that x alone. What's that? Minus 12 and what's that? Minus 6. Okay. And now what are we going to do to finish getting x alone? We're going to divide by negative 6. Whenever you divide by exactly same number, same sign, same everything. Negative 6, right? So it'll completely cancel and x will be totally alone. If we only divided by positive 6, that would be wrong because that would leave the negative hanging there. We want the negatives gone, the 6 is gone, everything, right? And whatever we do to one part, we have to do to all three to keep them in the same relationship they were in before. You know, however they were, which one was bigger or smaller before, if you treat them the same, they're still going to be the same. Okay, but you probably remember there's a special rule right here. When you multiply or divide by a negative, you must flip the symbol. It's got to go the other way. When you multiply or divide by a negative, you have to flip the symbol. Let me show. I don't want that just to be some weird math rule. Here's the y real quick. If you just think about it, it's got to be true. Like if you have 2 is less than 4. That's clearly, you know, if you look at a number line, that's clearly a true statement. You know that. Whoops, let me back that up a little bit. So right here, here's 2, here's 4. 2 is clearly less than 4. So if I divide both sides by like, let's say negative 2 or just negative 1, whatever, any negative, so what's that going to be? Negative 1 is less than negative 2. Is that true? Here's negative 1, here's negative 2. Which one's really less? The negative 2 is less, huh? So you see how the truth has to go the other way to see that that's what's actually true now, huh? The negative 2 is the lower one. It's the one on the narrow side. It's the lesser one. This one's less. This one's more. Yeah, so anyway, I'm just showing you that math is just simply following the truth there. When you divide by a negative, you must flip the symbol to keep with the truth. So right here, I've got to flip this one and this one. So it's really both. Must flip, I'll say both symbols. You got to flip them both because they're both have things on the right and left of them. We divided by negative 6 all the way across, didn't we? Here, here, and here. So that's, both sides of both symbols. So got to flip them. Okay. So then what do we got here? This is positive 2, right? Because 2 negatives make positive. This is regular x because everything else canceled like we wanted. We wanted x alone. That's perfect. This is positive 1 like we wanted. Okay. And so there's our answer, but it's kind of backwards. So I suggest it'd probably be easier for you. You don't have to. I mean, it's a fine statement, but it probably be easier for you to understand if you flip the whole thing around. If you want to, it's optional. You don't have to. So it'd be like this. It'd probably be a little easier for you to read. Oop, it's supposed to be equal there, huh? See how I just literally flipped the entire thing around there? Oops. So notice we had this whole thing here, and I just flipped it. The symbols, the numbers, everything. This is probably a little easier for you to read. This says x goes from 1 to 2. So now if I wanted to pop in a number line like this, like so, then it's going to go from open dot at 1, because there's no solid bar there, right, to solid dot at 2, and the shading is in between. So the x is in between. So there's the number line answer. And then the interval notation answer is pretty easy. That's parenthesis 1, bracket 2. Again, brackets because there's an equals bar here, right? You're right straight on the 2, but a parenthesis by the 1 because you're only around 1. You're not equal to the 1. You're only around the 1, so it's rounded like it has an open dot. You're not right on the 1. Excuse me. And so there we go.